Yeah, hello and welcome to our very last lecture in the lecture series, Climate Protection. As I already mentioned, Dietmar Siegele will present today as online guest. Dietmar Siegele is head of the unit Process Engineering in the construction at Fraunhofer Italia Innovation Engineering Center. Since 2019, he works now in Bolzano. He did his PhD in our department in engineering sciences in the field of energy efficient buildings here at University of Innsbruck. And he is civil engineer and is an additional master's degree in building automation. So he developed applications and use cases for topics of robotics, energy management, and facility management. But today, his presentation is on automation and digitalization in building modernization and energy efficient refurbishment. So what opportunities are there for the climate protection? Welcome, Dietmar Siegele.
Thanks, Rainer. So now I need to share my screen. I think I cannot, Rainer. Can you maybe make me again presenter?
Exactly, now you can.
Great. So here we are. I think it should work fine. So good evening also from my side. As Rainer already explained, I have quite a long title. Was a little bit of help of AI, I have to say. So sometimes to be creative, this is quite nice. But let's break it down, or we will see in the next minutes how this is composited, what we can do in this field also for climate change. In particular, today we are going to talk about building, as it is written here, building modernization and energy refurbishment. And one of our main research topics is automation and digitalization. So we will see how this fits together. Hopefully it fits together. We will see. It's not always simple, but we are trying our best. And already beginning to say I have a little bronchitis, so if I, from some time to time I have to put away my micro, don't wonder. I'm sorry about that. I originally planned also to be in Innsbruck, but unfortunately my health didn't allow me to come today. So anyway, I hope it will be a nice 60 minutes or 90 minutes what we have time. We have also in the end for sure some time for questions. And yeah, let's dive into the topic. First, maybe because I assume a lot of you know who Fraunhofer is. Many don't know that also in Italy we have a small department. We are called Fraunhofer Italia. Have at the moment only one institute inside Fraunhofer Italia, which is the Innovative Engineering Center. We are there still almost 14 years, so since 2010. Make applied research for public and private stakeholders of all sizes and economic sectors. We follow the Fraunhofer principles, so we are not inside the Fraunhofer Gesellschaft, we are independent, but we follow the Fraunhofer principles, which say we want to put things that comes from basic research to applied research together with companies, together with industry. We have a very interdisciplinary, multidisciplinary team. So we are in 3 groups. One group is about automation and mechatronics. One group is about robotics, and my group deals with buildings. As you have seen, I'm the head of department of the process engineering construction, which is a little bit a strange name, and I do not want also to explain it. It comes from the past. We are saying now at the moment more we are people that make digitalization and sustainability in construction. So we work always in both fields. The whole institute work in both fields. So we have at the moment, I would say, almost 0 project in the digitalization range that do not also include sustainability. We have also a small group that deals only with sustainability. That is like a transversal team that helps us also to focus on the topic. So that's really very important for us. Particularly in the last 3-4 years, that got without plans. It was just really the industry that was really focusing on the topic, luckily. We are at the moment 40 people in Bolzano, so not as huge as usually Fraunhofer institutes are. In Italy and Germany, we have around 25,000 researchers, so a little bit smaller, but which makes it also quite nice to work. My group has taken in the beginning, and I'm leading my group now since 2 years. We were thinking, what do we want to do and where is our focus? So a little bit also representing our vision. And we took one phrase that is, of course, very famous from Charles Darwin, that in the end, it's not that species that survives that is the most intelligent one, but it's in the end the one that is the most able to adapt to change. And that's something we have chosen out of stomach in the very beginning. One of the first sessions, we decided we had a look on some visions that could fit for us, and this we have seen fits really. So this fits until today. We are also not going to change it, and also in the presentation today we will see it's a lot about change. It's a lot about adaptation. So in the end, we can develop a lot of intelligence, a lot of smart solutions, in particular in digitalization, automation. But if people are not willing to adapt, then they are useless. And this we are also going to see. I have a group. We consist at the moment of 10 people. Also here, very interdisciplinary: architects, civil engineers, environmental engineers, physicists, everything you can imagine. Not everybody, of course, is a sustainability experts. They are also coming from other fields, but we have found a topic that let's say keeps us together. So let's talk a little bit about, and I start very broad, okay? So I think we have time today, and I think it's also good to start very broad. What are the challenges, and in particular the challenges in the sustainability in the construction sector? And for this, we have a quick look on the balance of sustainability. Because climate change, in the end, you cannot just put into one bottle. You need always to have a look on everything. And this, in my opinion, is still a good phrase to use: sustainability, even if it's a word that is used since long, and many people say I do not want to hear about it anymore. But in the end, it fits quite good what we have to take care of. So we have, of course, first ecology, we have the economy, we have the social aspect, and all of this together should help the sustainability. I'm in the meantime also saying there is something that should keep these things in balance, and saying these things we should try to keep these things in balance is quite simple. No? In my opinion, there comes something on top, which is adaptation. So things are changing. We are not changing these things. So we cannot change ecology, as we have seen. So the impact of the last years is something we can change only very slightly. But things are here, dynamics are here. CO2 emissions that we have done the last century are not going away. They will still keep, even if we stop now with emission of CO2, they will still be here. The same is with economy. We will have impacts, as we have seen also in the last year, like COVID, which we can just not control. And we have, of course, social impacts, also like in the moment wars, but also just how people want to deal with this topic, how people can deal with this topic, also from an economic point of view. We cannot just say we try to keep here the equivalent. We have to adapt. This is for me a little bit a stronger word to keep this whole house stable in the end. And I would like to go through, even if you likely have heard a lot already about it, but I know also not everybody of you is a building expert, so it's nice to have here really interdisciplinary wide audience today. So we talk a little bit about what are the issues, in particular, what are the issues on each of these columns for the construction sector. So where we can have an input, or let's say at least where is the most important impact we can have, or we have. So from ecology point of view, and I think, of course, this is one of the most important part regarding the climate change, it's in the end the basis for us humans, no? And I mean, this figure you know well, but I like to bring it because it brings it in a little bit different way, and in my opinion it also shows a little bit better the numbers that maybe people are already very sensitive to it, so or they are not reacting anymore. If somebody says 1.5 degree of degrees Celsius of temperature change, nobody's reacting anymore. But this figure here shows us the energy content and how much more energy is stored. And we have here once the part that is red, which is the warming of ice, land, and atmosphere. We have here in dark blue the warming of the water column in the very low levels, so 700 to 2000 meters. And we have the warming of the water column down to 700 meters. So why do I show that, or what can we do now? We can now, of course, fit our well-known diagram above. Here split it into northern and southern hemisphere. And as we can see in the northern hemisphere, we have already reached much higher temperatures compared to the southern hemisphere. And why is that the case? And that for me is an insight that was very important to understand also. It's because we have there a lot of sea. No? In the end, we have there a lot of water that at the moment still stores energy, and that in the next years has still the potential to cause dramatic changes in our world. So, and then if we put this on the warming of land, so we try to smooth it down, even if it's of course physically not correct, you cannot overlay this. So scientifically, this is more not a diagram that you should take scientifically correct. We can see that where changes are happening are also somewhere else, and mainly somewhere else, and maybe changes that we can even not do back. So like coral reefs, or likely also climate changes, weather changes, not only climate changes, but weather changes where we have also an impact, like this was this year in Milano for an airplane. So never happened something like this. This was very spectacular. And sorry, here I just see I have I forgot to translate something from German to English. We have always to deal with 3 languages, so don't even wonder if there is also an Italian phrase somewhere inside. Where we have in the construction field the most possibility to really create an impact is of course in heating and cooling. So 40% of the final energy consumption in Central Europe, there are numbers that are a little bit higher, there are numbers that are a little bit lower, I have to say, but let's assume 40% are attributable to buildings. So in the buildings we live every day, in the buildings we work every day, and of course it's one of our most important environments. We consume also the most energy. And the major part for this is going to old buildings. So heating and cooling of old buildings has really a dramatic input. And this leads to a phrase that we decided also, we have at the moment a big project, Fraunhofer internally, so together with the Fraunhofer Gesellschaft, almost 10 million euros, that for us and for the next years, and we have to say we are already too late. We say that in the meantime, we are too late. That existing buildings are the key to climate neutrality, prosperity, and independence. So to all the things that we have seen in sustainability, it's not just about climate, but of course also social impact and also economic impact. From the part of economy, I would like also to explain you a little bit something that you maybe have not seen so far, and I hope you have not seen so far. And these are things that makes me always a little bit doubtful. So when I'm starting a new project with customers, I'm always asking these questions that are arising now that I will explain you. I will explain you in the next minute. The question here is, where is the promised efficiency? So what we can have a look is, and I take here numbers for Germany, but you can find these numbers for every country in Europe, and the same is for US. They look a little bit different. They look sometimes even worse. Germany is a country that is growing, so we can slightly growing, maybe half growing, some people would say. It's not China, but it's also not a country like maybe you can compare it with Italy or maybe or Spain, where we have also some dynamics, mainly also in the construction sector, which maybe influence these numbers. So we know in Germany nobody would worry about the construction sector, maybe in the last months, yes, but before nobody would worry about them, and everybody knows that Germany is a country with very high industry and very important for industry. So what we can have a look here is a diagram on the labor productivity. So we could discuss now very long what is labor productivity and if the definition is correct or not. And we could also have other definitions, and I think it was also worth to have a look on other definitions, but they show the same thing. We can also have a look on this on the CO2 efficiency. Also, they show the same values. So we can here make the labor productivity, which in this case, the ratio between the, oh, I'm missing now the English term, I'm sorry, but the Bruttoinlandsprodukt, I hope everybody understands it, divided by the people working in the sector, okay? So we have a basis of 100%, which was 1990. And as you would expect, as you heard maybe, overall economy is always increasing. So we have an increase in the last 30 years of about, I hope you can see my mouse now, 40%. So we have every year approximately 1.2, 1.5% of increase in the productivity, which in the end is also the increase in economics, no? Which is the economics increase. We see in here the classical drawbacks, let's say. COVID is not inside here so far. Maybe the numbers were not sufficient here, but we can see here the drawbacks of 2008. These are the classical ones, so no, nothing particular. So you can also overlay other diagrams. You will see same response. You will say same behavior. Let's have a look now to the manufacturing industry. So here in Germany, of course, it's mainly automotive or a lot of automotive, but also other parts, but a lot of automotive. And we can see they have an increase that is higher than the rest. So they are performing better, let's say, no? Maybe. So also here we see this peak in 2008, which was going down, but which was then also again as it was before, okay? What we see from the 90s until now, it's quite linear, no? Okay, here maybe before it was going a little bit up before the financial crisis, but after that it is again linear. And I think if you put here a line, it has almost the same steepness. Maybe even it's getting a little bit flatter. So maybe it's even not anymore like it was maybe in the 90s or in the beginning of the 2000s. If we have a look now in the construction sector, and that makes me always worrying, we have productivity in now, which is the same as 30 years ago. If we go back in time, we just took this diagram because you can see here already everything and something more. If you go back in time and you see even the 60s or 70s, so also where boom was here, the construction sector was even at 120, 125%. So what does this mean? 60, 70 years ago, people built, constructed. Of course, in that time, energy efficiency was not that important, but in general, we talk here about now first about creating a building where we live every day, where we work every day. We were much more productive. So one person built, or one construction worker, one architect, one engineer, you have to put everybody in the bottle there, no? And mix it, has constructed more than now. Okay, that there you can discuss, okay, maybe there have been motivation, I don't know, or there have been still people that were working 60 hours instead of 40 hours and so on. So maybe a lot of impact. But anyway, the last 30 years, we still had no increase. So why is that the case? No. And if you have a look into the numbers in Italy, they are even decreasing. So we are at 80%, 85% at the moment. People are also having a lot of explanations for that. Not really a single one, from my opinion, is valid. So what is the issue? Even if we look in how we construct things, okay, and this you can also then make it to energy efficiency, or to just simply build new houses or renovate houses, modernize houses, doesn't matter. This is something that had been constructed 700 years ago, more than 700 years ago. You can see, even if you are maybe not an engineer or an architect, you can see a lot of wood, a lot of beams. Okay, this is what is today. Not always, but this is what a lot of times it looks today. Find the difference. No, there is no difference. It's exactly the same. I can even tell you that the machines that are using the people are of course now mechanized. No, they are electroized, but in the end, the procedure is always the same. The methods how we connect these things together are the same. You can see here a nail. You can see here on the bottom, on the top was a nail. So there's no difference. And that's one of the explanations why the construction sector has still this low productivity. We can also have a look here, and this is a little bit more provocative because I honestly saying I cannot prove it, and honestly saying also I'm working for customers that would like to work with us together on digitalization. So they are coming to me because they are saying I would like to have a nice tool, I would like to have something on a mixed reality tool sets, virtual reality, and very nice stuff. We do also things with robotics and everything. But I have a hypothesis. If you see here the increase that was in the beginning of the 90s, also the years before, and now you can see in the last 10 years, it's going slower. Now you can say, okay, this was 2008. That had such a big impact that we still see this in the numbers, and nothing changed, and even getting worse or whatever. No, in my opinion, it's not the truth. In my opinion, there are 2 points. If we think that digitalization has started, okay, 1990s, in the 90s, there were the first computers we started in the construction sector, slowly changing from paper to computer work. Text and so on was written in a text program as it is now standard. Anyway, maybe it started in the 2000. It started really, 2000 we had the first internet bubble that exploded. It started there. If I'm now saying digitalization makes us more efficient, where do I see that here? I don't see it. Maybe I see it until 2008 because there was something, maybe there could be an exponential growth, but after that it was not anymore here. So in my opinion, it is a little bit, and in construction site it's even worse in my opinion. It looks a little bit like this picture. So 30 years ago, there have been 2 people. They were standing in front of a piece of paper. They were maybe having a walkie-talkie on a big construction site. No mobile phone, just talking. And there was an engineer, an architect or something that was talking with the head of the construction site, and they were talking what are the next steps. What do we need today? Today, at least 5 people are there. We have still the same plan there, which is a 2D printed plan. We have at least 2 electronic devices, 1 laptop, 1 tablet. Yeah, and 5 people that are looking very strangely on one thing. In my opinion, the way how we deal with digitalization is bad, and it makes us even less efficient than it was, and also for a climate change, it's not a good impact. So this is something that is my thesis, but I will also show you that it's that we are working on it to change it. But in my opinion, everywhere where digitalization is put on something and it will help us and it will solve us the solution, or we will put something on your heating and on a heat pump, or on your house, we put there some sensors. No, it's just simply not working. Makes things more complicated. You need now to buy a tablet, which is of course an impact. This has an environmental impact. You need more people because people are just they are overwhelmed. They do not anymore get these things, no? And that's something which I say in the beginning, because I think it's very important to understand the things that you will also see in the end. There are a lot of things. They are not so easy to handle, and they should always be also evaluated on a long-term scale if there is really an impact. We can also have a look on another diagram, which I like really a lot, where you can put 4 sectors. And you can put on one of the axes the number of elements in the system. So we talk now just generic about the system, of course, then a bit more specific on construction side, on construction in general, but you can put that also on a car or on your life, on your daily life. You can put these things. You will also see that later. You can put these things also on daily life operations. We can put this on the bottom. We have a low number of elements, and on the top we have a high number of elements. And on the bottom, we draw the dynamics. So how fast is something changing? No? We have left low, we have left on the right side high. So if we deal with low dynamics and a low number of elements, so I'm going there and ask you if we can go and drink a coffee. So I'm going there, I'm not writing you something, you can still decide because you can think there, then we go, we take the coffee and so on. It's a simple thing. So it's just, you think I have time, I go, yes. If the number of elements is getting more complex, so I don't know, the coffee example maybe does not fit anymore here, but if the number of elements is very high, then the things are getting complex. You can also imagine if you have to do a lot of things to do, even if you're working quite in peace, if more and more things are coming, even if without pressure, but things can get complex, no? Or if you get once such a piece of paper and you have to start reading and understand what is inside there, you have automatically a higher number of high elements and things are getting complex. If at the same time the dynamics is increasing, but we have a low number of elements, things are complicated, okay? We will see that in an example why I mean that. And if we have a high dynamic and a high number of elements, things are either tending to get very complex, but most of the time they are tending to get chaotic. If we see now what this means is that if we have this category of simple, we can just use simple means and we have solved things. If it's getting complex, then usually we use an adaptive approach. So like, yeah, you're getting a paper of literature, you want to read it, you are new to the topic, so you will have an adaptive approach. You will start reading, then you will see things not understand, so you will go somewhere else, ask something else, do research on internet, whatever. So you will try to adapt. Or if you have a very high, very complex project, then you are going to ask a colleague, work on that, try something, go back and improve it. If things are complicated, usually it helps that you are more structured. So first this, second this, third this, and so on. And then in the chaotic, usually people tend to make trial and error. So I try something, if it works, perfect. Otherwise, we make a mistake, which can also have some consequences. If we make this figure now in a different way, we can also draw it a little bit differently. We can also draw it in such a way that we have a simple range when dynamics are low, complicated, complex, and chaotic, just as we had it before. It's just a little bit more advanced, this diagram, okay? It considers some other things that, in particular, this complex range you would not see otherwise. Sorry. If we draw now construction site, and we start maybe with very old construction, then we had, I don't know, Stone Age maybe, I don't know, I'm not an expert on this, I have to say, but we had here very simple houses, no? We had here some pieces of wood, we had here some insulation material, and I say, by the way, really insulation material, because it's insulation material that now a lot of people, also we are working on again to focus on this natural insulation material, no? So this was insulation and rain protection at the same time. And maybe a piece of, I don't know, they didn't have nails, so maybe just some other soft wood to keep these things together. So we are here definitely in the range where it's simple. No? Things are really simple. We have just three types of materials, nothing else. And it was very structured, and everybody that was taught once to this could do it again. No. You didn't need cranes, you didn't need whatever, you didn't need a lot of complex things, but it was a very well insulated house. You, you made, of course, a fire in the middle when it was too cold. If it was too warm, you just opened both sides and there was the wind going through. Then time grows, so things are getting more complex. So of course things like cathedrals, they were complex and they are still complex, no? But what helps here, of course, is saying, okay, we can make some plans, no? In the construction sector, we have seen plans are not always working. So in particular, time plans, cost plans are never working. So what in the construction sector, something that in software engineer and also in a lot of other things you find all the time now, since more than 10 years now, agile. Being agile. So saying, I have somebody that I can ask to. We have a team that is meeting in the morning. We discuss what are the next steps that we are doing, and so on and so on. Classical agile elements. If you have never worked with agile, I would recommend you to read once what it is to get an understanding of it. We are working just in that way, I have to say, and it's making things much more efficient. And things like this, as we can see here, a lot of workers were working there, more 100, 200, 300 people now. You can only handle with such an approach. So you're getting people to you, you're talking with them, what are the next issues to solve? You're looking just for these issues, and then you're working on exactly that, and then you plan the next step. It's not trial and error, because you're not saying try it out and we will see. You're doing together planning of the next steps that are really predictable, where you know that they are coming, where you can in the evening say, you have done this. This is agile. And this works for construction sites. This works for construction sites very long, and it's still working in most of the construction sites. If things then are getting even more dynamic, so let's say there have been mistakes on construction site. People are asking that you always build faster, faster, faster. This is a big issue in construction engineering. They want faster the results, so they wait very long for giving you budget, but then they want, after 6 months, they want already everything. Then things tends to get, of course, having a higher dynamic. And then things are getting chaotic. So things like here, like Stuttgart 21 in Germany, is one of these things. Things are very complex. Things are very looking maybe firstly nice and fancy, but in the end there was a lot of time spent on planning, discussion, and so on without any outcome. In the end it's constructed, in the end it's very in delay, in the end it's very out of time, it's very out of budget. So simple approaches that worked 200, 300 years ago, no? Here on the cathedrals, are not considered anymore today. And this leads to these chaotic things. And you can project this diagram at the moment to many, many situations in our life, and also to climate. So one goal is to reduce again the number of elements, because we know that the dynamics we will not be able anymore to reduce. So people are like they are. This is social. They will not change. But we need to understand how to reduce again the number of elements. So this is one of our core research, how to make things more simple again. Then we have the social impact. And here I have just one slide, and for me it's very important, the message that social is difficult. Changing people is impossible, and we should even not try, in my opinion, because it's their freedom. This diagram that I just showed you before, and I'm sorry, this is in German, but I didn't find it in English, shows the same things as we just discussed before. No? And what here is important is that people have safety, so they can know that tomorrow the world is still the same as it is today. Otherwise, we get into chaos or anarchy, and they need to accept the solutions. So if they do not accept these things, then we have the same thing. We have anarchy and we have chaos. And this is something we have to avoid, of course. No? But this is something I would not like to discuss today because we do not have enough time for this. And one thing that is very important for me in this part is adaptation, because still a lot of people also in construction sector are only thinking until, oh, we need to put insulation. Point. Then it stops. So we are still in a situation where for most people this discussion stopped. Oh, we put there insulation 16 centimeters, isn't it enough? No, it isn't. Our buildings in future must be able to have much more. Our buildings in the future must also resist to the climate changes. So discussions that people are not dealing so much at the moment. So if wind forces are changing, if loads are changing, also maybe heavy snow loads, even if they are very rarely, but maybe they will be more heavy, more high, we have to adapt. And these are still discussions that, in my opinion, we have still to start, also in many parts. Also because some changes, and this was the diagram that I showed you in the beginning, no, some changes we cannot make back anymore. There is no way, and they are coming. And with the efficiency chart that I wanted to show you, and we will also come back, I want to give it this message already now is construction sector is too slow. We will not be able to modernize, make energy refurbishment in that slow range that we have still, because maybe we have 0 years to be honest, but maybe we have 7 years or 6 years according to the European Commission. Maybe 6 plus 3 years as they are looking at the moment to get our buildings to better classes before they give us some taxes, which then in the end impacts also social, no? Because people are not willing to do that if they are getting forced. And on the other side, and you will also see that example later, there was a big social experiment in Italy and a big construction experiment in the last 3 years, and it turned out that it's not working, and we will see why. So this is Bolzano, so where we are situated now, and this was like 100 years ago, a little bit more than 100 years ago. City looks very different now. In particular, what changed here a lot is that years ago there was still area that was not used by human people. No, it was still given for the nature. And I take always South Arrow because this is really extreme here sometimes, because we use all available space for apples, for wines, and of course for buildings and hotellerie and everything. So for nature, there is always less and less space. And also this is something that in modern construction is not considered well and has to do something with adaptation. Because if we have a look on here, this is the Neutech Park. Here we have our seat, and a lot of other companies have also their seat here. A lot of very innovative companies. But this is the building. And I always make, let's say, the game here, find the mistakes. And for me, the mistakes are obvious in the meantime. And climate change will not care about these mistakes. So here are no trees, or almost no trees. We have no living organism in this thing here. There is no bee, there is no butterfly, there's nothing anymore available. There is, there are more or less no birds, I have to say. If there are birds, they would even fly against the buildings because they don't understand why they should be black. There are no plants a part of the screen, which is even forbidden to walk on it. So people are looking bad at you if you're walking on it. As I just mentioned, there are no butterflies. And in particular, if there is a heavy rain, where is this water going? And this water is simply going, they collect every water, as long as the rain is not too strong, because if the rain is too strong, water is everywhere, then it's in the garage. Below is, of course, only garage. It goes directly into the river. it's not kept anymore back. And that's getting also an issue in the next years, because if we are not looking on our water resources, on water management, this will be a big issue. And also these are things that in construction sector should be a little bit more considered, and are at the moment not as in this discussion, not because many times really just about energy efficiency. What I want to talk now a little bit is about automation, okay? So the main things we are dealing with, okay? So I tried to give you a little bit of an overview of a lot of my opinion, a lot of my experience I made in the last years. In particular, this gap between efficiency, how it should be, in particular looking on digitalization. Automation in construction is almost not available, so there is no gap, but in digitalization. And also considering that it's in the end, we have also an issue how to do this work that needs to be done. So we have here a lot of potential, but also a lot of risk. So at the moment, the issue is, and this slide is very complex, so don't look on it. I just copied it from a project we are making together now with, as I just mentioned before, with the Fraunhofer Gesellschaft. At the moment, we use very traditional process in construction site. We do a lot of manual handling of mass-produced building materials. So of course, building materials are mass-produced since years, but how we handle them is very, very manual. And we have always a prototype. In all buildings, it's always a prototype. Every single building for every person is new. There's really no standardization. So if you're not into construction sector, there's really nothing standardized. You can get everything what you want on the way you would like to have it, in measures you would like to have it, and that you can just imagine. The same is with planning. Every architect is starting from zero. I hope there are not too many architects in there, or engineers. It's the same. Nobody deals what happened in or really thinks about what happened in the project before. They always start from zero. So there is way too much manpower inside, way too much complexity. We will also see in some seconds. Way too much material consumption, as we have seen in the pictures before. We have seen it with the wood. No, we would know how to make that better also with wood and not with so much wood. It would not be necessary. Just simple engineering. Way too much cost, also because of a lot of material consumption, a lot of manpower, and way too much time in the end. And time we don't have anymore, in particular when it's about energy refurbishment. So if we talk about energy refurbishment, traditional energy refurbishment is this picture here. So you make a scaffold, you take some insulation material, most of the time still EPS, so something made out of oil, which is maybe not bad. This is something you have to see in a life cycle analysis. You need to consider everything. You need to consider what you can do with this thing afterwards, what you can save, of course. So it's not said that it's bad. Made by people. So every single plate taken by somebody, put plaster on it, put it on the wall, and afterwards drilling some holes into the wall and making it again more stable also. Everything from hand, step by step. Looking on one detail, and these are things that you get from the people that deliver you these materials. These are details. So even if you're not an architect or engineer, you can just count the numbers. So there's 21 numbers. And 21 means in this case also more than 21 materials. So we have just in this simple detail. So this is a window with a wall. The wall even did not get a number because it's already existing. Insulation material and the connection to the floor so that it's not getting wet. We have more than 21 materials and of course more than 21 steps, because every step here is really done manually. So one material is one step done by human people. So we are really, really Stone Age. The difference is that before it worked with 3 materials, wood, a little bit of natural insulation, and maybe something to put everything together. And now we need a lot of other tools to do this and a lot of other materials. Getting these things out and use it again, maybe. Recycling. I don't talk today about recycling. I don't talk today about reuse. I'm going to tell you because it's a very difficult topic and also something we should not discuss at the moment in construction sector, in my opinion. It's impossible. Hopefully we will find in 50 years when this facade needs to be redone, either ways how to renovate this facade without pulling it off, or to find really efficient ways how to reuse these materials. But if you look at this at the moment, this is catastrophic. You cannot reuse these things. Why I'm saying I'm not talking about recycling, so if you expect something here from circular economy and everything, we have too long lifetimes. Buildings are made to stay there and should be made. In my opinion, it's even important that they should be even more made for that they are standing there for 100 years, 200 years, 300 years. Also insulation that maybe is against environment and has more water and so on, it should be made that it holds as long as possible. Then I do not have to care that much about recycling. Or at least we gain some time to think about what and how we can do this recycling. But investing here too much time in something which where we have still to solve other issues, in my opinion, is not worth to be discussed. There are things that should be recycled also during construction site and so on and so on. But what we put there is a time when we will find a solution. The moment it's important to react. We have a solution for this. We have prefabricated facades. You can find here also some machines. You can find big machines. They make also a lot of things automatically. I have to say way too much automatically. So there's most things still man work. The only difference is instead of making it on a construction site, you make it somewhere inside. You can then go to construction site, you bring these large elements, you put them with a crane there and you mount them. Looks very nice, in my opinion. They're also very stable. They have a lot of features inside. We can put even, and this was my research topic, also in Innsbruck, you can put even their ventilation systems, you can put their heat pumps, you can put there everything. You can really put there everything you can imagine. There was a lot of research and is still going on a lot of research, and there are no limits. So, okay, found, no? Solution found. So, quite fancy, no? Maybe. So, if I'm going to tell you now the issues, and if I'm going to tell you the price is coming because of the issues, then you're maybe thinking, okay, why? You understand maybe why these things are not standard. So here are some pictures that I've stolen from somebody I know. Things in the end are that we are working in something that is existing. So there are still old components, there are still old things that must get out. There are still connections that must be done that are very complicated to make. There are still some insulation, like here, polyurethane foam, that is also not so, here you can see, not so easy to either get it away from old window, neither than to say this is a sustainable material. Or also that sometimes you need to have a lot of space to mount them. Also because they are huge and very large. And as you can see here, like there are no balconies, or sometimes they make balconies away. So a lot of things in the end that are very complicated, which makes these things in the end very expensive. So these things, unfortunately, even if they are very nice and I like them a lot, I've done a lot of research on them, they cost still the twice of a traditional insulation. And if we know that most people are still thinking if they should make a traditional insulation to save money and to save energy, and most people are still not convinced of doing it, then I cannot sell to somebody something that costs twice. The issue is, and this is something we have seen here in Italy, and I come now back to that point. Here, 3 years ago, so during COVID, the government decided to make super funding. So they call it super bonus. So they gave you money that you do the renovation. They really gave you money. So you could get 110% of your investment you could get back. So you can get on top 10%. There were done some banks and some other big companies that were also using this. So they were saying you get the renovation for free. We take the 10% as organizational effort, and you will get a renovated house. Seems like optimum, no? Seems like that, okay, everybody must wake up now in 3 years and do just like this, and everybody else that isn't doing this is stupid. Unfortunately, the social component was not considered in this fact. And another component was not considered in this fact, and this is the efficiency and the things we can do in construction. So we have one quote that is, I don't know if I translate it correctly to English, I have to say, which is a renovation quote. So energy refurbishment quote, you can also say. So how many houses are each year renovated? No? How many percentages of houses? And like in Germany, this number is at below 1%. So it's, I think, at 0.86% in the last year. In Italy, it is the same. So before, let's say 3 years before, it was the same. Okay. What do you think it is now? Or after these 3 years, because now they stopped because they realized that they don't have money anymore. And they realized also, by the way, a side effect that the company said, oh, let's now increase prices. We have a little bit more than 1%. So the increase was really, really small. It just led to an issue that now renovation is even more expensive than it had been before, and led to something that can even not meet back. So it's an issue. It's not a solution, no? And then we have a lot of other things, and we have now not so much time anymore because I'm talking too slow today. But as I said before, we need also to consider water management in future. We need to consider that buildings are a life habitat for people, no? So people want to live in buildings. People should have also in cities the right to live in a good way. And green and all of these components must have a very important role also in the next years. And also European Commission has seen that and made also some laws regarding these things. So what are solutions? Solutions could be the things I just showed you, prefabricated facades. This is definitely one solution that in the next years will come. There will be changes, in my opinion, and in our opinion. We are working, for example, at the moment on facades that are smaller, so people can handle them again without big cranes, because this big cranes was an issue. Allowing also to combine it with traditional methods, because we are not getting rid at the moment of them. But also at the same time trying to solve these issues, which is quite difficult. One thing that is important there is digitalization. So we must have a workflow that starts from the beginning and is going consequently to the end. So I must have a digitalization workflow that makes these things that I'm showing you here. So survey of a building, deciding what should be put there, how it should be constructed in the construction site until elements are coming to construction site. Fully automatic. We have simply no time. So we do not have enough architects to handle all of these things. Bureaucracy must be really settled down to a minimum. Italy is here really crazy with these things. But the European Commission is also planning things that are not making these things simple. Bureaucracy must be reduced to an absolute minimum. We must then have the chance to use there also digitalization method. So part of these things must be automated. Otherwise, we will not increase this number. We will not increase this value. We need a rate that is much, 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 much higher than at the moment. No? So prefabrication, adaptation, maybe on construction side, making things more simple to use. Also maybe letting more people work on these things, even if they do not have the training on this, but at the same time ensuring the quality is good. We did like here we have a prototype that we did where we can do things like this. This is still quite a old video, but I don't have a newer one. We are also working on, or it's much more advanced now. So we can have now a house We can identify from a 3D laser scanner. You go there with a device, you put it there. This is done in half an hour. You have your full outdoor facade on millimeter range. You can put it into artificial intelligence. You can visualize planes that are smooth to it. So you can imagine a wall is not always straight, but it has also some holes and things like this. But that adapts these things and gives it to the fabric with exact measurements that must be done, that it can be then exactly fitted on the construction site. This is one thing that is still missing, and one reason why these things are very expensive that I just showed you before, so these prefabricated facades. We must also understand very simply what is the impact. In the end, it doesn't matter if I have 1 or 2 kilowatt hour per square meter in year. This is the unit that we calculate. So how many energy we need to heat or to cool. If it's 1 or 2 more, nobody cares. What we need is quick solutions for these things. Quick, of course, consistent. It should not be completely wrong. It should not be something that is not working. That's clear. But we should also start being a little bit pragmatic. And then we need to get to overcome the complexity. So we have an issue with the complexity. So what we are working on is, for example, things you know very well, I would say, ChatGPT, on a different way, so that we can also work with programs with that. So I do not need to understand anymore each of the steps I need to do in a program. I want to do a certain thing. Like here, I would like to understand what materials are in my database, or I would like to run a simulation, and I can just write it. Or like here, the output is I get 21 kilowatt hours per square meter, and I'm asking now if it's feasible to reduce it to make maybe like 90 kilowatt hours per square meter here, and then propose what is the best thing. And artificial intelligence can do that. So it's calculating, it's a little bit speeded up. Calculation takes a little bit longer, repeating me what I could do. I could make insulation with a more optimized value. I can change it. I can do the calculation again just by typing and writing. In our opinion, one way how to get again rid of this complexity, because if you have a look on programs at the moment, then you will, the first thing that somebody will answer you, architect. The architect in the end is the one that coordinates everything and should coordinate everything. He will say, I need an expert. I need an expert for this. I need an expert for this. And it's correct. We need the experts. But at the same time, the expert costs money, the expert costs time, and so on and so on. And for a lot of things, we think expertise will go into artificial intelligence. Other thing that we made is, sorry, likely sound is way too high. I hope not. Making also factories on site. So how to produce maybe panels on the construction site. Here we showed it for a brick because this was something we wanted to do. You do simple things. You do things also again with a chatbot, and you can then create or let the automation do on the construction site. You take the container, you put it to the next construction site, and produce there again the next prefabricated facade in small elements, in smaller ranges, but highly customized. So things that people want, they want highly customization. We need it sometimes because we do not know what we have to expect sometimes. So if we open a wall and we see it's completely a different material, we have to decide that we have to do something different. This we can solve maybe with things like this. So here we are doing a brick cutting that is then done automatically. I do a little bit fast forward because otherwise we do not come to the conclusions, and if you have still questions, there's no time. So conclusions, last slide. In my opinion, for some goals, we are talking here about 1.5 Kelvin, we are too slow. So construction sector is not ready. We slept. We slept in research, we slept in construction, we slept in government, we slept in the laws, we slept in the social component, we slept everywhere. It's too late. We will not make it. It's impossible. But we cannot stop, of course. So there comes one important part on that we need to adapt. Okay, so we need to consider from now on that buildings must be very, very efficient in the future, but at the same time, they must be resistant enough also for changes in climate. and this is something that is still, in my opinion, a discussion that is not started very well. We need to assess this construction sector's base. So we need to work on that, and it will not be simple. And I don't have a solution for that, to be honest. I'm hoping that somewhere a startup is formatting like Tesla and doing a revolution. Things that are working at the moment, so the things that I just saw you before, this is, for example, energy sprung, they are not the solution. So they don't make it correct at the moment, but they have the good ideas and the correct approaches. But I think the final solution we have not seen so far. We have to rethink public funding strategies, in my opinion, because we should definitely fund these things. So we should put the funding earlier. We must put the funding in the manufacturing. We must enable the people to do these things, because in the end, then it's so economic and good, and also socially accepted, that people are just doing it. So they're just doing it, and that's it. There is no discussion anymore. So at the moment, where money is going is, in my opinion, sometimes on the wrong place. It will not be possible without, but we have just seen it's also not possible with. We need to simplify things. This is in construction, in my opinion, the case, and in digitalization and automation, the case. Without being simple, people don't understand it anymore. People don't want to understand it in a certain point anymore, and they are not working with us anymore in that case. So keeping it simple, and in my opinion, keeping it simple means also, okay, how did people heat 100 years ago? Differently to us, no? We have comfort at the moment. And maybe we need to rethink comfort. So maybe we need also to rethink, do I really need in the whole house 20 degrees, 22, 23 degrees all the time if I'm not there? How could I adapt that it's comfortable where I am? Maybe I take a pullover instead of a t-shirt. So things that everybody must also understand on its own, and solution there, I don't know. Simple solution seems, of course, to be high energy prices, but this, in the end, as we have seen in the diagram before, can also lead to some social issues. And we need also to find a balance in the trust in technology with simplicity. So technology is coming. I still don't know if digitalization will be once able to really make a boost again. I hope it, because I see it. I was grown up with digitalization from zero, so I don't know anything else than that. In my opinion, if you do it correctly, you can gain a lot of efficiency. But if we are doing it like we are doing it at the moment and keep it in that way, then I see a little bit even that it's a barrier instead of something that enables us to be more fast. And that's it from my side. Thanks a lot.
Yeah, thank you very much. That was really, really interesting. A long story short, yeah, but really, really big issues you mentioned. So, any questions in the audience? So for the people participating online, you can just write in the chat. And if here in the lecture hall, please raise your hand. I'll give you the microphone that also people can hear you in the online. So, are there any questions from your side? Some icebreaker from my side. Discussion will come to. Yeah, but I think what you mentioned is really right about the complexity. The complexity is always rising, and with rising complexity, the prices are rising in the building sector. But I think it's an inbuilt mechanism in our economics. So if you just think about building services, if you are a building services engineer, you want to earn money. And if you do complex things, you earn more money. So if you have a look on our systems for heating, that's a very
Way too
simple
complex.
thing. But it's very simple. But if you have a look how it's done, you have a lot of control valves, you have a lot of electronics, a lot of ducts, and so on. So it's not necessary to have, but you can earn a lot of money out of that. So nobody is saying stop this rate of complexity. Nobody. And the user doesn't know if it's necessary or not. He seems a good thing should be complex. And if it's not complex, then it's too easy, then it's cheap, and it's worth. It is not worth the money. So how to come back to that simplicity? So if you have a passive house, the heating system is really, really uncomplex. It's it's easy. The control strategy is easy. The power is low. The complexity is low. But even in passive houses nowadays, we find complex systems because the building services engineers and mechanics and all want to earn money out of it, and they do so. So how to solve this problem? Do you have some idea for that?
Good question. Really good question. I think that's why we're working on it, and I have not found a solution. I don't know a very specific answer, because in the end it's of course social. So if people are accepting this, then it's like it is. Yeah, construction sector is grown, so I'm still hoping that once there comes up some startup that sees exactly this point and see that they can still make money just with making this incredible hole that we have and fill it, because there is an incredible hole, and this will also make a change. I mean, there are a lot of initiatives since years now for low technology buildings, but in the end, if somebody thinks it's fancy, then they make it. Huh? So it's difficult. I still think it's everybody must come back here to something, also on its own, on her or his own, to understand what is necessary, what is not necessary. Where I think digitalization can maybe help, it can also mislead. It's also dangerous, saying that maybe in future everybody has access to even more knowledge than before. So knowledge is getting broader. But at the same time, we see already now how this is used, and that people put their information that is for them important in this cloud and in this solution. So difficult. I don't know. So I don't know an answer, to be honest. So discussion, word for discussion.
Yeah, in the beginning of your presentation, you said it should be in the service of mankind. That was very interesting. You mentioned it in terms of digitalization, in terms of automation. It should be in service of mankind. So, and the same is with energy. Energy should be in service of mankind. And people don't want energy. They want the service. They want warm buildings. They want cold refrigerators or whatever. They don't want energy. And if you do it with less energy, it's even more simple. Yeah, and then, but nobody asked the people what do they want. Only what can I sell them? Then it's
Yep.
a different assumption. And you also mentioned the subsidies. So the subsidies are rising. You mentioned the example in Italy, 110% funding for the prices will rise, and the complexity will also rise because you have money for building
doing
more
strange things. Yeah. Yeah.
Yeah.
Absolutely. That was one issue.
What was your suggestion for funding? How could you change the funding system as it's now? What could it be better spent for the money?
In my opinion, the government should make joint ventures. So they should fund exactly people like startups or innovative companies that really state they want to do this with high money, because there is the money, no? The money is there. And that they find a solution And maybe it will not be the most efficient way how to put the money also on that point, because public funding in the end is never efficient. But to enable such people, such companies to really work focused in very, very, very short time on something that can change the whole construction industry, in my opinion. So that's my suggestion. I don't know if it works, could work, but the way we have it is working at the moment is not working the way it is done at the moment.
So to spend it for innovation, that's your opinion?
In the end, for innovation, exactly. Yeah. Of course, not only for research, no. So I'm a researcher, but so don't put away the money. I don't want it. But of course, researchers must be on board, and they will be on board because it's a logical consequence. But it will be innovation, but it should be for these companies that really make this dedicated innovation. By funding that should not be paid back by making fabrics that can do these things. And distributing it into different ideas, very different ideas, so not really always the same, also in new approaches, new ideas, making joint adventures with this company, and when the money is lost, it's lost.
Yeah, there's a question.
Thank you. As you said, you're a researcher, and I thought that your topic was really interesting as well. But of course, all that research is kind of lost if it doesn't get to the decision makers. So how do you target decision makers, or how do you make them listen to you and communicate your findings? Do you have any on that?
Of course. So we at Fraunhofer, we have exactly that idea. So we get 1/3 of our funding for internal research. So where we try it out, for example, this mini factory. This we get from public. Okay. Then we have usually 1/3 that is projects that are public funded, so but where we have to apply to them, classical research projects, and 1/3 we make with industry, and there we try all the time to focus exactly these ideas. So we make first the preliminary research in internal projects to show what is possible, also really specifically, and then to go there and say, look, this is possible, we can do that technically. It's already a prototype here, so we can also promise you this could be ready in 1 year. You can sell it in 1 year. Isn't that a deal? Let's do it together. The issue there is, might have been exactly that point, that people are then having, or companies in particular, established companies, they are afraid in investing in that things. They don't get the money, they don't get the risk capital. But we are trying it. I hope it will work.
Okay, thank you. Another question? In the chat, there's also no question at the moment. Yeah, you mentioned to reduce the number of parts, and that's also works for building and constructions. That's some way to make it less complex. In terms of refurbishing, you have already some first prototyping for easy installation systems. I think that goes also in the direction reducing the number of parts. Could you explain some more about your work on this? You showed last time in Bolzano.
Yeah, definitely. So like so prefabrication, and also as we have seen, if it's a big element or if it's a small element, doesn't matter in the end. We are focusing more on small elements because we think they are then also can be adapted on a construction site, so you can deliver them as material as you do it at the moment. You put them inside a container, for example, and it's coming in the correct measurement, and you just put it on a facade. Without having long lead times of fabrics, without being able to scale these fabrics, because a fabric costs you 100 million. Maybe this container can be done for 100,000. So it's scalable. A fabric itself is not scalable. But such mini factories, yes. So we could dare say we bring more into material. We make the materials more intelligent, maybe more innovative. So materials are good, but usually they need some other things. So like EPS panel or also like a hand panel, they need some plaster that you can fix them. You need some components, some screws, whatever, so that they're really tight with each other. No? They need some painting in the end and so on. And if everything must be done on the construction site and everything must be explained to a worker, everything must be planned before, everything must be budgeted before, in every part something can go wrong, and in every part somebody wants to earn money. So if we try to do that in prefabrication, in my opinion, it will work. We have at the moment a gap between this theory so that it can work and it can be even more cost efficient because not everybody is earning money, and it can be faster. But we see at the same time these big modules like these initiatives like Energy Sprung, so this is one of the most famous one in Europe. They are costing the twice of the money, and we don't know why. Honestly speaking, people don't know why. Some people say because of missing digitalization, so they do not have a continuous workflow. Yes, it's true, they don't have. It's essential, you need it, definitely need it, but at the same time, it's not the only thing. And that's the reason why we also said we maybe want to make these modules again smaller, something that is used like now. Maybe this has a reason why it's this size, and that can be also made on construction site or further finally made on construction site. Prefabricated somewhere else, like EPS panel is also prefabricated somewhere, but maybe this EPS panel has already something on top. It has already the plaster on top, or maybe it's not EPS anymore, maybe it's hemp, and it's a sandwich element that you can then cut on a construction site, or a machine can cut it for you, and steps are less complicated. So as worker, you do not have anymore to read how to make a certain plaster, how many water you need for that plaster, how many time you need to wait until you can use it, how many time you need to use it, how many time you need to wait until it's dry, and so on and so on. So this makes things complex, no? And this could be maybe solved with these approaches.
Yeah, that's interesting. I think then maybe we should not only have to reduce the number of parts, but maybe also the number of players on the building business. So I think the one-stop shop issue is a step in the right way. So if you have one player doing all and everything, even the customer, it's easier for the customer. They have one person to talk to. They have one who is responsible for all and everything. The discussion is all in between the one-stop shop company and not between many players with having some issues in between and so on. So maybe this is also a reducing number of parts in humans in this case, or in organizations or companies. Yeah.
Absolutely, and we for sure don't need it everywhere. So there will be still buildings that will be renovated because they are used in a different way, or there will be also new buildings, definitely. We don't have to do it everywhere there. So there should be also some kind of design freedom, how to do it. But if it's about energy efficiency and energy refurbishment, goals are quite clear. And how to do it is quite clear. So there is really one goal that we are getting much more efficient.
Okay. There's a question. Doesn't look like this. Yeah. So then I would say thank you very much for your presentation and the Q&A session. It was a long time for you. You have some health issues. Thank you very much that you did it anyhow. So that was really great. And
Thank you also.
Thank you very much, and good luck for your health.
Thanks. See you. Thanks to all of you.
Thank you, and goodbye.